Hi everyone. So in that last video, we looked at this interesting pattern when the exponents get smaller and smaller. So as we go from a power of 2 to a power of 1 down to a power of 0, each time we divide by whatever our base is. So if we use the same example as 2, from 4 to 2, we divide by 2. And then here, from 2 to 1, we divide by 2. And that's how we figured out that any number to the power of 0 is always equal to 1. But what happens if we keep that pattern going here and we get into the negative numbers? So if we divide 1 by 2, we get 1/2. And then if we do that one more time, so same thing, we divide by the base, divide by 2. 1/2 divided by 2 is 1/4. And just to expand on this a little bit more, remember that 1/2 times 1/2, that's the same as dividing by 2, multiplying by 1/2, is equal to 1/4. So looking at this, we can see some interesting symmetry between our positive exponents at the bottom here and our negative exponents at the top here. You can see here we have a 4 in the denominator, and then here our power is equal to 4. And then here we have a 2 in the denominator, and then here our power is equal to 2. So the exponent rule that we end up getting from this is that anything to the power of a negative exponent is equal to the fraction where we have that same base and power, except now it's positive and in the denominator. So we have x to the power of negative m is equal to 1 over x to the positive m. And remember, we can always go in the opposite direction too. So if we see a fraction with a positive or a positive power in the denominator, we can always rewrite it as an exponent with a negative fraction or a negative exponent instead of a positive exponent. So let's go through a couple examples here because sometimes it can be a little tricky to figure out the applications of this rule, but we'll try it out here. So if I give you 1 over 64 and I say, I want you to try writing this as a negative exponent, what you might want to do here is go, well, I know that we have a rule that deals with things in the denominator, but that's not an exponent yet. So how could we rewrite that as an exponent? Well, 1 over 8 to the power of 2, I know that that is equal to 64. So now that we have a exponent with a positive power in the denominator of a fraction, how would we apply our rule to this? Remember, our rule is x to the negative m, x to the power of any number, is equal to 1 over x to that power. So what I think we are going to end up getting here is 8. So remember, 8 is our x. 8 is our x from the rule. And then 2 is our m. So we're going this way in the rule, turning it into a negative exponent. So we get 8 to the power of negative 2 is equal to 1 over 64. So let's do one going in the opposite direction here. And I would say that most of the time we do end up seeing it going in the opposite direction. We typically see stuff where we start with a negative exponent and go, oh, I'm not sure what that means. Let's turn it into a fraction that I can read a little bit easier. So what about 2 times 3 to the power of negative 3? Let's think about that one a little bit. So, like in some of those problems from the zero exponent video, we have to apply the order of operations to this. So we've got our old pal PEMDAS here. We've got multiplication, and then we have an exponent. The exponent goes first. So our first step is going to be to go 2 times 3 to the negative 3. Well, I know that to rewrite that, we want to go 1 over 3 to the positive 3, applying that same rule we used before. So then we're going to simplify one more step here, and I want you to go ahead and pause the video and see if we can rewrite this as just a fraction or a number, whatever the most simplified form of this is. All right, so my next step, if I was going through this, would be to go, okay, I have a 2 multiplied by a fraction, so I'm going to go ahead and just turn this into one fraction here. So I have multiply across, and I have 2 over 3 to the third. And then my last step to simplify would be to calculate this exponent. So 3 times 3 is 9, and then 9 times 3 is 27. So we found that over here, 2 times 3 to the negative 3 is equal to 2 over 27.